Welcome to another Fenestration Canada podcast.
This podcast is a presentation of Quanex Building Products. For more than 30 years, Super Spacer Tri-Seal from Quanex Building Products has been the ideal warm edge spacer solution for commercial and architectural glass. With its unique triple seal design, Tri-Seal provides structural strength, durability, and outstanding thermal performance in the most demanding applications. Learn more at quanex.com. This is Tech Talks, live conversations about the regulatory environment with Al Yagalis.
Hello everyone, here we are again for, I think, what is episode 8 of Tech Talks. As always, the show is presented by Quanex Building Products, so we thank Quanex for their support. Without further ado, I'm gonna go with you, Al, because I think we have a pretty packed show and we have tons of people on the line. So I hope you're pretty rested, because you're probably gonna get a lot of questions today.
Sounds good. Well, good afternoon, everyone, and we're happy that you could join us for today's episode, which we're calling a guided tour of the code. And this is a guided tour specifically to people in the window industry, primarily Fenestration Canada members. And Fenestration Canada member companies are primarily serving the small building housing market, the Part 9 market, you might say. And so I'm going to be introducing you to the code from that perspective, the highlights and kind of the structure of the code, so that you have an idea of what parts of it apply, what parts of it are important, where do I go for more information. I think some of you might be wondering, will a copy of this presentation be available after the show? So the show itself is going to be posted on YouTube, but we're going to make the slide deck available on the Technical Center page, or on possibly also on the member resources page of the website. And maybe Steph can talk more about that later as to where he'll put it. But the slide deck will be available as a reference document for you, so don't feel like you've got to capture the screen or write everything down. This will be available to members as a resource. So, a guided tour of the code. And by the code, what we mean here is the National Building Code. And the first edition of the Canadian National Building Code was published in 1941. It's been adopted over the next 20 years. The provinces and territories adopted the building code. And right now, it's updated on a 5-year cycle. This is a little bit different than the United States. They update their codes every 3 years, but in Canada, it's every 5 years. And of course, the current version of the code that's in effect across Canada is the 2015 National Building Code. And whether you're in a province that has a provincial code or a province that's referring to the national code, this is the edition that is now in effect coast to coast, according to the Codes Canada website. So why do we have provincial building codes if we actually have a national building code? So this is a question that I think might concern some people, or a logical question that you would have. And it's basically because in Canada, construction is the domain of the provinces. They regulate what goes on in their territories. And so because construction is a provincial jurisdiction, provinces either adopt the National Building Code as their code, or they incorporate the requirements of the national code into their provincial code. And they do this on their own timeline. And this also, I think, frustrates some people because, it's 2020 and we're using the 2015 national code, but then we have these provincial codes and every one of them has a different year of issue. And it seems confusing that we have multiple codes of multiple years. But what you need to know is that behind all these provincial codes, the underlying code is the National Code 2015. And the differences between the national code and the provincial codes is not that great. In some areas, it is greater than others, but with respect to the issues that affect our industry, there's fairly little variation in terms of the provincial codes with respect to the national code. So currently in Canada, we have 4 provincial codes: Quebec, Ontario, Alberta, and British Columbia. And we have 1 city that has a charter that allows it to have its own building code. And so the city of Vancouver has its building bylaw, and it is actually based on the BC Building Code, but it's a separate code document just like any other code. It's big, it's fat, it's heavy, and it covers everything that the national code covers, but with provincially, and in the case of Vancouver, municipally targeted requirements. So all the other provinces that do not have their provincial code adopt the national building code. And all the provinces adopt it with some changes that are adapting to local conditions of climate or historical construction or other reasons. But there has been a real emphasis across Canada to actually harmonize with the national code as much as possible. So we're seeing less variation in provincial codes, and definitely they're becoming more harmonized with the national code over time. The national code is the one that it's useful to look at, though, because its organization, its structure forms the basis of all the others. And it's published, the 2015 is published in 2 volumes. And we'll notice that there are 3 divisions. Division A, called Compliance, Objectives, and Functional Statements. It's a fairly short portion of the code. It's got very important but high-level information. For people in the window and door industry, we're not going to be looking at Division A very often. In fact, hardly ever. But we're going to talk a little bit about some important things that are in Division A that you should know. And then there's Division C, which is a significant portion of the code called administrative provisions. And this is basically for building officials, the people that actually administer the code in the real world. So that leaves us with the Division B, which is called acceptable solutions. And essentially, these are the specific requirements that buildings must comply with, are laid out in Division B. So that's really the part of the code that we are most concerned with. And I would like to just point out that one of the reasons the code is in 2 volumes is because Part 9 is very, very large in the National Building Code. It accounts for 644 of the 1,400 pages in the National Building Code. So it actually is published in its own volume in the print edition or in the PDF file. So some things you should know about Division A. And Division A has largely to do with compliance to the code. And I think it's important for us to understand that this code applies to the design and construction and occupancy of all new buildings, and also the alteration, reconstruction, demolition, removal, relocation, and occupancy of all existing buildings. So what you need to know is that even though the code, we think of it as something for new construction, it is intended to apply to existing buildings as well. So technically, when there's an alteration, a renovation to an existing building, a change of use of that building, maybe from a commercial application to a residential application or something like that, or to a public assembly application, occupancy, then the building code applies. And so technically, anyone that's doing renovations on your home, if they're doing plumbing, if they're doing a wall repair, they're supposed to be complying with the requirements of the code that's in effect. And technically, any replacement windows that are supplied to existing buildings are also supposed to comply with the code. Now, this is often not enforced. Most municipalities in Canada do not actually require you to take out a permit for something like replacing windows and doors. So there may not be a building official looking over your shoulder to see if you're complying with the code when you put in the replacement windows. But the intent of the code is that it applies to all buildings, and technically those replacement windows are supposed to comply with all the applicable provisions for windows that would apply in new construction. Any questions from our listeners at this point, Steph?
For now, I don't see any Q&A.
Okay. By the way, I would like to encourage the listeners to the show, feel free to ask questions while I'm covering content here, because we can answer questions in real time. If you've got a question about something we're talking about here on the screen, feel free to raise your hand. Steph will notice that and let me know, because we don't have to leave all the questions to the end. We can actually interact here. A second thing you should know about Division A, also related to compliance, has to do with this idea of acceptable solutions. Why are some of them called acceptable solutions? So in section 1.2, 121, sentence 1, compliance with this code shall be achieved by complying with the applicable acceptable solutions in Division B. So Division B contains the requirements of the code as we think of them, but there's another compliance path, or using alternative solutions that will achieve at least the minimum level of performance required by Division B in the areas defined by objectives and functional statements. And these objectives and functional statements are contained in Division A. So again, it's rare that we will have the opportunity to use alternative solutions in Part 9 buildings in new construction, but it's not out of the question. And all municipalities across Canada, as far as I'm aware, have in place some kind of procedures for the use of alternative solutions. And this was something that was introduced in the 2005 code. Before that, the code simply had a set of requirements. You must do this. This is the way you handle, whether it's window installation, whether it's window performance, whether it's egress issues or whatever. But the building folks realized that if we tell people what to do, then there's not going to be much innovation. And a lot of times the requirements of the code are tough to fit in. This is a real big deal in Part 3, which deals with fire protection. Very often, as you design a building as an architect, you've got distances to an exit. You've got various fire protection things. Sometimes the requirements might even conflict from one to another. And sometimes the building design is such that implementing the letter of the code is not possible or not desirable. And there's an alternative solution can be proposed that will solve the problem a different way. And so that from the 2005 code on, we've had this ability to propose the use of alternative solutions when the acceptable solutions are too cumbersome or inappropriate for a particular building. So it's good to know that this pathway exists in the code. It's rare that we would have to use it in our part of the construction world, but it is there, and you'll hear about it from time to time. And so what used to be prescriptive requirements are now called acceptable solutions. So we have basically two main ways of complying: acceptable and alternative compliance solutions. So let's look at some things you should know about Division B, titled Acceptable Solutions. This is what we used to think of as the prescriptive part of the code. It tells us what the energy performance should be. It tells us what the structural wind load performance should be. It tells us, all those various requirements of the code that we think of as the law or the letter of the code is in Division B. And parts 1 to 7 and part 9 are common to the NBC and to all the provincial codes. So all of them have a 1 to 7 with the same titles as we see here, and part 9. But the provincial codes will have different uses for Part 8. Some of the provincial codes have parts 9, 10, 11, 12, and 13, like the Ontario Building Code. So provincial codes can have additional parts to the ones that are in the national code, but the ones that are common to across Canada are these ones that are on the screen. And if we take a closer look at Division B, we see that in the national code, there are 9 parts to it. And of those 9 parts, there's 4 that have some relevance to folks in the window and door industry. And first and foremost, we'll start with Part 9, because that's where most Fenestration Canada members are doing their work. So Part 9 covers housing and small buildings. And it's a very large part of the code. It's almost half of the code. But basically, it deals with the performance requirements that we test our windows and doors to, such as NAFs. In most of the country, it also contains the energy performance requirements. In Ontario, those are in SB 12, Special Bulletin 12, but in the rest of the country, the energy requirements are in Part 9. So most of the requirements applicable to windows and doors for Fenestration Canada members are in Part 9. But you should also know that Part 5 has some important information. It deals in Article 592 and 510.2, it deals with the structural, air, and water performance of windows in large buildings. And it allows the use of methods other than just NAFs to qualify structural, air, and water performance. So Part 5 is very important. Sometimes Part 9 tells us that we should refer to Part 5 with respect to windows. And so there's a specific portion of Part 5, these articles 592 and 510.2, actually they're subsections 592 and 510.2, that are relevant to windows and doors and skylights. Part 4 of the code deals with structural design, and that covers everything from the fundamental building structure and also the attachments to the building, such as cladding on the outside of the building, and windows and fenestration is considered cladding. So Part 4 contains the structural design requirements that engineers must follow to design structural design of glass, window framing, and anchoring, the attachment of fenestration products to the building structure in large buildings. And those Fenestration Canada members that work on large buildings are typically going to be required to provide shop drawings, and those shop drawings will require an engineer stamp usually, and those are reviewed in the context of other engineering documents on large buildings. So Part 4, we don't deal with directly until we get involved as manufacturers with having to provide glass that conforms to certain levels of wind loading. And usually this is something that is, let's say the design team checks that on large buildings. There isn't really a lot of verification of that in Part 9. And finally, Part 3 is important because it deals with fire protection, occupant safety, and accessibility. So for example, any accessibility requirements that pertain to doors are in Part 3. Egress requirements for windows are in Part 3. So there are issues that affect our products, particularly doors, but also windows, that are covered in Part 3. So these are the parts of the code that actually have relevance to people in the window and door industry. Any questions at this point, Steph?
Not yet. I feel like I guess you're explaining too well. We're not getting questions. Maybe. Oh well, we have one. So Eric's asking, in which part of the code are the energy specifications for large buildings?
So that depends on the provincial code. That depends provincially. I believe in British Columbia, it's in Part 10. In Ontario, it's in special bulletins like SB 12, and there's another special bulletin for the large buildings. That can vary from province to province. So I can't say for all provinces what part it's in, but it's a good question.
Okay, so maybe we can maybe with next week. I think that next week you want to talk about the same topic. Maybe we can look and see if we could find that.
Yeah, we're going to continue with the code topic next week. We are expecting to have a guest with us on the show,
Okay.
Robert Jutras. He's with UL, Underwriters Laboratories. He's their principal engineer for building enclosure. And he's involved on several of the code committees and has been involved in a number of code changes that are relevant to our industry. So Robert knows more about the code for window and door people than anyone I know. And I'm really glad that he's agreed to join us on the show next week. So I think on next week's show, I'll be doing less explanation and there'll be more discussion with Robert and with our callers.
Great.
So we do encourage everyone to come back and join us next week for more discussion on the building code.
Great. And for now, I mean, like, use your Q&A button or your raise hand button to ask questions as it goes. We have another one here. Richard's asking how and who are alternative solutions determine acceptable. Do those alternative solutions have to be proven to meet the performance guidelines of the A440 guide?
So that's a good question. Basically, alternative solutions are granted on the basis of a building. So you can't say, hey, I have a new technology for doing something like installing windows, and I want to get that approved for use across Canada. Alternative solution won't let you do that. Alternative solutions are permitted on the basis of a specific building. So, and it's typically an engineering consultant is typically the kind of person that is going to apply for an alternative solution. And most municipalities have some kind of defined paperwork. They have forms that you use to apply for an alternative solution. And those forms indicate what level of documentation or information is required for the municipality to consider the alternative solution.
Okay.
So, for example, so you basically need to contact the municipality. It has to be for a specific building. Clearly, the person who's building that building has to be interested enough to allow this alternative solution to be presented. So you, as a supplier of a product, cannot apply for an alternative solution. But for example, there's a project that I was contacted about last year, where a vinyl window manufacturer was working with a condo association in a city in Ontario, where the condo association had aluminum windows. They were drafty, it was cold, they were old, and they wanted to replace them with vinyl windows. And at this time in the code, in the 2015 code, vinyl windows are still considered combustible framing material. And so there are restrictions on the overall area and on the spacing of combustible windows. So the code says you have to have at least 1 meter spacing between the window below and the window above. It says the windows have to be separated from other windows with non-combustible construction. And it says you can't have more than 40% of the wall area of a fire compartment with combustible window framed windows. So if you fit within these rules, you can use them. But if your windows are bigger or more than 40% area, you have a problem. And so what they wanted to do is they wanted to propose an alternative solution. So you had a building owner that was willing to put forward an alternative solution request. You had a consultant working for the owner, in this case, the condo association, and they were applying to the municipality to be allowed to present an alternative solution to allow the use of the combustible window frames on that project. And they had a specific rationale that they were proposing to justify that. So that is one way that an alternative solution can be used. And there have been a number of buildings in British Columbia, especially in Vancouver, now that have been built with combustible windows using alternative solutions. So, this is one way that an alternative solution can be used.
Okay.
But it requires a client willing to hold up their building permit until this alternative solution works its way through the building department before this thing can proceed. So that's kind of how the alternative solution works and how it could be applied in our window industry.
Okay. Well, that's all the questions we have for now, so maybe you can keep going.
So we'll carry on. Yeah. So we're looking at Division B. And now I want to look more specifically, and this is really the last portion of our, I guess, formal presentation content today, is looking at specifically the window requirements, the window performance requirements in Part 9, because I believe that there's not enough awareness of the specific code language here for people in our industry and even among building officials that I think is really important for us to understand. So in Part 9, we have 3 subsections that deal with the performance of windows. Subsection 9.7.3 is titled Performance of Windows, Doors, and Skylights. Subsection 974 is titled Manufactured Windows, Doors, and Skylights. And it deals with how products in the scope of NAFS comply with subsection 973. So think of subsection 973 as the highest level document. Says this is what windows, doors, and skylights must do. We're going to look at that in a moment. 974 tells you if you're a manufactured window, door, and skylight, this would be like the factory glazed products that are in the scope of NAFS. Then 974 is how you comply with 973. But not all windows are manufactured in the factory. There are site-built windows, doors, and skylights. And the code defines these as products outside the scope of NAFS. So subsection 975 is written for site-built windows, doors, and skylights, how they comply with the performance requirements in 973. So we'll take a closer look now at subsection 973, titled Windows, Doors, and Skylights, and Article 9731 is titled General Performance Expectations. And so this is what the code wants your windows, doors, and skylights to do. Windows, doors, and their skylights and their components, and this is separating conditioned from unconditioned space. So it applies to windows on exterior walls, not windows inside a building. They shall be designed, constructed, and installed so that when in the closed position, they resist the ingress of precipitation into interior space. That means keep the water out. Resist wind loads. Be strong enough to support the window and the glass in the window against the wind loads that it will be exposed to. Control air leakage. There's a few other requirements there: resist insects and vermin, resist forced entry, and be easily operable. But those are hard to measure. There's no test for insect ingress. Forced entry, there is some test methods for resisting forced entry. And be easily operable, that's kind of covered in NAFS, but really there's no measurement. We don't rate a window on being easily operable. Okay. So I'm highlighting the portions that are measurable. Skylights and their components shall be designed and constructed and installed to resist snow loads. We're going to skip over main entrance doors because that actually is not meant to apply to the front door of the house. And that's something we can discuss at another time if people disagree, but this is not meant to be an exterior door. And storm doors, again, are not our main concern here. So those are the main requirements there in sentences 1 and 2. And in sentence 5, it tells us how we can comply with this. Compliance with the performance requirements described in sentences 1 to 4 shall be demonstrated by complying with the requirements in subsection 974. Let's have a look at 974. 974 is a way of complying with 973 if you are selling manufactured windows, doors, and skylights. And what are manufactured windows, doors, and skylights in the code? Well, it said this subsection applies to windows, doors, and skylights covered in the scope of NAFs. That's what is a manufactured window, door, and skylight. So manufactured and pre-assembled windows, doors, and skylights shall conform to NAFs and the Canadian supplement to NAFs. So this is how your products comply with 973. So let's go back to sentence 5, though, at the bottom of the screen here. 974 is one compliance path. The other one is 975. What is 975? 975 is titled Site-Built Windows, Doors, and Skylights. And what are site-built windows, doors, and skylights? Well, it says these are windows, doors, and skylights that are not covered in the scope of NAFs. So this would be curtain wall, storefront, any finished, like a large skylight with multiple lights of glass that is assembled on site. So these kinds of products are not in the scope of NAFs. We don't test them in the lab for NAFs. And so subsection 975 applies to site-built products. It's how they comply with 973. And then separate from 974 or 975, it says, or design and construction conforming to Part 5. So this is a really important or. It's a very important provision because it means regardless of whether you are a manufactured window, door, and skylight supplier or a site-built window, door, and skylight supplier, you can use design and construction conforming to Part 5 to demonstrate compliance with the structural, air, and water performance requirements in subsection 973. And basically, the applicable portion of Part 5 is in subsection 592. And there it tells you that the goal of Part 5, environmental separation, is for windows essentially to have structural performance, air tightness, and water tightness. And you can demonstrate that through engineering and test methods that are different from those in NAFs, or you can demonstrate that through using NAFs in the Canadian supplement. So there is this option for other methods than just NAFs to qualify your products, even in Part 9. And it's right here where it says, or design and construction conforming to Part 5. And some of you know that I've written a series of articles on the NAFs in Canada blog over the years. And one of those articles did talk about the alternative to NAFs testing in Part 9 buildings. There's times when people want a one-off product from you that's not been tested in the lab. There's times that people want to use an imported product that was tested in another country, not in Canada. And the code does not mean to exclude you from using those products. And that's where the Part 5 option is there in the code when the product has not been previously tested to NAFs. So it's really important for us to understand this about the code, that we do have that option, because there are times when it's a deal breaker if you know, in terms of securing work. And there are some building officials who do not fully appreciate that that option is in the code, but there's a lot of window and door manufacturers that don't fully appreciate that that option is in the code. So that's something that I think we can talk about and consider in future tech talks. But for now, I just wanted to introduce you to these ideas and to realize that the code may have more flexibility in it than we may have appreciated previously.
So we do have a couple questions,
Sure.
if you're ready for that.
Yep.
So, okay, so we have Daan here asking, can you explain a little more about the alternative solutions for combustible windows? What solutions are there that are acceptable?
Well, it depends. I mean, like I said, there are guidelines on the spacing and vertical and horizontal spacing of or separation of these windows, and on the overall area. And to explore this option, I would really recommend that you work with fire consultants. Part 3 of the code, which deals with fire protection, is probably the part of the code where alternative solutions are used the most. And so there are consultants who specialize in working with architects on buildings to come up with alternative ways of complying with the code. So some of the options that have been considered in the past, let's say you have an apartment building where you have concrete balconies projecting at every floor. So even though there's supposed to be 1 meter of separation between the window above and the window below, where you have the balcony doors, there's very little separation. There's just a concrete slab of the balcony between the patio door below and the patio door above. So consultants have argued to say, well, we don't need the 1 meter because the balcony itself is acting like a shelf, preventing the fire in the suite below from setting a fire in the suite above. And maybe to back up a little bit, the reason we have these restrictions on combustible window frames in the code is because the code is concerned about fire jumping vertically from window to window to window and going up a building. And so the concern of the code is we want to limit the risk that the fire on floor 7 is going to have huge flames shooting out that could break the glass, light the frames on floor 8 on fire, and the flames would end up burning the suite on floor 8. And then when the fire on floor 8 is big enough, the same thing happens and it goes to floor 9 and 10, 11, and 12. Mm-hmm. So this used to be a really big risk in buildings about 100 years ago, when the interior of many buildings was built out of wood and the exterior was clad with stone or brick. And in those cases, and they had large windows with wood window frames, and one of the fire risks was that a fire could start on a building across the street, burning embers, because these buildings weren't sprinklered and because fire departments couldn't control those big fires. You could have burning embers landing on a windowsill of a building across the street, lighting those window frames on fire, and that fire would spread through the framing of the wood building, and you would have building after building after building burning without of control. This was the risk that they tried to manage. Okay. And one of the ways they tried to manage it back in the day was to reduce the size of windows and the spacing of windows. Since then, the code has introduced non-combustible construction. We no longer build most of our large buildings with wood. In fact, for many years, you couldn't build large buildings with wood. It's only now that mass timber construction that is designed to resist the fire problem are now we can start building large wood buildings again. But for a long time, the code just didn't allow that. Okay. And the other thing is, in the 1995 code, they introduced sprinklers. So the risk that this part of the code is trying to manage no longer exists. But technically, we're concerned about vertical fire spread. So what the consultants will do is they will argue about maybe the balcony slab is preventing vertical fire transfer from the patio doors. So maybe we can exclude the patio doors from the 40% calculation. These are the kind of arguments that the consultants...
It's 100% case by case, from what I understand.
It's totally case by case on a specific building. Yeah. And I kind of went into a lot of detail, but that's kind of the way it works. There's no... really, you have to have a specific project, a client who's interested in your product, and a consultant that can evaluate your situation and say, yes, I think we can make this work.
Yeah.
Or they might say, sorry, your situation is so far out of bounds, we can't do anything for you.
Okay.
But fire consultant would be the way to go.
Okay. So I hope that answers your question. We have a couple more here. So would you rather we keep going, or you want to?
Well, this is my last slide.
Okay, perfect. So
My last slide is here, and we've already covered it. People can read it if they want. It's basically just summarizing the point I just made. So we can take questions from here on.
Okay, perfect. So let me check. We have Nirojan here asking, or basically, asking, with these codes, why haven't we eliminated leaking windows or done a better job of managing water? And now I can.
This is interesting. And who's asking that question again?
So it's Nirojan. I don't know from what company.
Is the question about leaking between the window and the wall, or is it leaking through the window?
Well, so maybe we can ask for more precision if the person who asked the question here wants to precise. But from what I understand, what I can read from the question, it's basically why haven't we eliminated leaking windows or done a better job of managing water? So I don't know exactly where, but okay. I guess in general, right?
Well, I would say the manufacturers, I guess, with NAFs in the code, manufacturers are required to test their products in the lab, and they're supposed to be testing the same product in the lab that they sell every day. And so technically, manufacturers, if they achieve the rating of 200, 300, 400 pascals in the lab for water testing, and you're selling a product with a label that says it's rated to that amount, your product better be able to perform to that if it's tested on the job site. So the reality is, though, that if your manufacturers are only selling to single-family homes, their products generally don't get tested at the job site.
Okay.
So it's possible that there are manufacturers whose quality control in manufacturing is not adequate to ensure that that product that they sell every day will actually perform in the field.
Okay.
But the good manufacturers, their products will perform in the field. And certainly any manufacturer that's selling products to multifamily buildings like condos, buildings of where there's an architect involved, in many parts of the country, these products will be job site tested for water penetration. And so these products will not leak, or the manufacturer will go out of business. So basically, people who serve that market, their windows don't leak. The other place that windows could leak, though, is in the installation. And with installation, we have some real challenges in the industry, because who installs the window? It's not the manufacturer. It's a framer. It's a siding contractor. It's a laborer on the job site. And that's a real disconnect in our industry. And this is an area that we're very concerned about at Fenestration Canada, is we're concerned about qualification of installers, and we're concerned that the people who actually install our products in buildings are responsible to make sure the joint between the window and the wall doesn't leak, but we have no control over what they do.
Yeah, the install problem we touched on, I think, in the last 3-4 shows. So if anyone on the show right now, if you didn't have the chance to participate, you can always find them on YouTube or on our website. But maybe they could find answers there. So from what I understand, the products themselves and the code, the product, the code, and the testing should ensure a window that is not leaking. So if it's still leaking after all that, it could be the install or maybe quality control at the job site.
Yes.
Okay.
Or even quality control in the factory.
In the factory, okay.
This is up to manufacturers, but I would say by and large, I think the windows we build today are superior to the windows we built 10, 15 years ago as an industry, 20 years ago. Their products are much better today, and I think manufacturers recognize they have a responsibility here. And for the most part, I think Canadian window manufacturers are doing a good job in this area.
Good. So we have Roberto saying, I read that site-built window and doors don't have to meet NAF certification. Is that a real thing? How?
He's correct.
Okay.
The code doesn't require certification, but sometimes people use the word certification. They just mean testing.
Okay.
That the products have to be tested to qualify them as having some kind of performance rating. So I think that's really what he's asking. And yes, site-built windows and doors. Here's the thing: the code does not require site-built windows and doors to be tested to the NAF's standard. And the NAF standard excludes site-built products from its scope. It says it's not the right standard to use. If your product is not one of the products named in the standard, you're not supposed to test them to that standard. But the code still is concerned about the water tightness, the air tightness, and the structural performance of site-built products. So how do you prove that? If you're going to prove air tightness, you're still going to have some kind of a test. It may not be a NAPS test. It may be an ASTM E331 test. But you're still going to need some air tightness testing.
Okay.
You're going to have to show that your product resists water penetration. It will have to be either tested in a lab to an ASTM standard, or it will have to be tested on the job site.
Okay.
So the code still expects the site-built product to have structural performance, air and water performance, but you will have to use different methods to qualify those properties. It will not be a label like NAF's label or a product tested in the factory.
Okay. So just so you know, we have a lot of questions and little time left. Well,
okay, I'll
still
try
15
to
minutes.
make shorter answers.
Well, no, it's okay. It's just so you know, so we can pace the whole
Sure.
show. But so we have just a follow-up question from Roberto, who just asked this one. So are folding doors still considered site-built?
Folding doors were never explicitly, well, there's some argument. There was a NAFS 11 when it was published, excluded folding doors from its scope.
Okay.
So that would have made it a site-built product under the code. But what some people thought was, well, if it's a site-built product, it doesn't have to be tested. And that wasn't true.
Okay.
The code still expects that product to perform. It's just that it doesn't expect it to be tested to the NAF standard. Now, many manufacturers of folding doors did test them to the NAF standard anyway. And you could always do that, testing it as a specialty product. NAFS allows you to test a product that isn't listed in the standard as a specialty product. But during the NAFS 11 cycle, there was a technical interpretation from the Joint Document Management Group that manages the standard that says, that lifts the exclusion of folding doors and says you can test folding doors to the NAFS 11 standard. NAFS 17 actually now has folding doors as a product type with performance classes and with specific testing requirements and everything else. So folding doors are now definitely a product inside the scope of NAFS 17, but NAFS 17 is not yet referenced in the code.
Okay.
So the short answer is, if you're making folding doors, you better have testing for that product. If not, you may face the requirement to prove on a building by building basis that your product has structural air water performance. So take your choice, take your risk, but a lot of manufacturers, probably most who are selling folding doors across the country, are probably testing them to NAFs, either as specialty products or testing them to NAFs 17.
Okay. We have Terry asking, when looking to comply under Part 5, to apply correctly, would this include structural engineering, design, on-site air, and water testing?
I would say if you don't have structural engineering and if you don't have any testing, then job site water testing would be one of the things that would probably be required for your product to be accepted on a project.
Okay.
So yes, engineering is one way. The code allows an engineer to use what's called rational analysis to make sure that the glass in your product, that the framing of your product is stiff enough to resist wind loads, that the glass is designed for the wind loads, that the product is attached to the building adequately. And so, yes, engineering can be used in place of NAFS testing, and other types of testing can be used to qualify air and water. But at this point, it's a kind of a case-by-case situation with a particular building officials in a particular area that you have to discuss this with. So you might need to work with a consultant who can help you walk through that. And this is something that we can discuss in future Tech Talks. I do have presentations on this subject as well.
Okay,
so.
Great. We have David asking, would site mulling of large units or site assembly of separate units fall into different code specifics?
That's a good question. If you are mulling the products together using the components and the instructions of the manufacturer, then that product can be qualified through NAFS testing. It can also be qualified with a combination of NAFS testing of the individual units and AMA 450. AMA, the American Architectural Manufacturers Association, has a whole range of window standards. And one of their really useful standards for the window industry is AMA 450, which deals with mulling individual units, windows together. The nice thing about AMA 450 is that it doesn't require you to test every combination you build. It allows an engineer to evaluate your product line and all the different operator types and products that you might want to mull together. And the engineer can evaluate the range of options you have, distill those down to a couple of test cases or worst case scenarios. He can use engineering to design the mullion. And the only extra testing you would have to do, besides the testing you already have for your individual units, is a air and water test of the actual mullion joint. So a manufacturer can work with a test lab or an engineering consultant to have AMA 450 reports for their mullion connections. And you can qualify all of that most economically with an AMA 450 report in your existing NAFS testing.
Okay.
So that's an option, has not been used enough in Canada. I know for sure that CanBest does those AMA 450 reports, so does UL. And there are some engineering consultants in the country as well, such as RDH, where I worked for prior to coming to Fenestration Canada, that will do that as well. So, and there may be other firms too. These are talking about the ones I know about. So there is a way to properly qualify these products under the code. If you are not doing this, if you are field mulling the products, if the contractor is buying your windows and assembling them together on the job site, that's not a tested condition. That is not your responsibility. It's the person who is mulling your product who's responsible to comply with the code on that building. And if a building official challenges what they're doing, they're going to have to find a way to prove that the structural, air, and water performance are addressed for those field mulled situations.
Good. We have Stephen asking, single-use plastics are increasingly being banned by governments due to environmental pollution. Is the code going to be more restrictive to plastics use in the future?
I don't know of any initiative underway in the code to do that. But I think there is a concern in the plastics industry, there's a concern in the PVC industry that the government might be looking for an easy way to deal with single-use plastics. And one of the ways that the government might do that is the government might decide to classify certain types of plastics as toxic materials. And if they classify them as toxic materials, then without a code process, without consultation with the public, without consultation with manufacturers, those plastics could just be decreed to be added to a toxic materials list and regulated that way. And the concern of the industry is this is not a very good way to go, because all of a sudden, the usual process in the code is to have consultation, discussion, participation of affected parties in the regulation of something. And it would be a mistake to risk classifying really useful products like vinyl windows, uh, as a toxic material without any proof of any harm arising from their use. So I think there is some concern that discussions that are currently underway in government circles on regulation of single-use plastics, there's some concern that if the government chooses the kind of an inappropriate way to handle that, it could create problems for the industry. So, but I don't see
Yeah.
any connection between that and the code.
Yeah, and right now, like I'm just always wondering, like he's right. It's about single-use plastics more than what we use, and you know,
This is it. And you have rigid plastics that are used as durable building materials
yeah,
that will last 30, 40, 50
yeah,
years in installed applications. This is not the same thing as a plastic bag, as a styrofoam cup,
yeah,
as a
exactly.
takeout container. It's not litter. And there's actually an initiative at the Vinyl Institute of Canada. They're
Yes.
they're discussing a project to start looking at recycling of window frames, so
Yeah.
that when window frames are removed from project sites, that the material can be collected, recycled, and reprocessed into new window frame materials. So the industry is looking at a kind of a circular supply chain for the durable plastics that we use in construction. So they should not be classified as in the same category as the single-use plastics that are polluting the environment. These are materials that can be reprocessed the way we reprocess aluminum and steel and glass.
Yeah.
We can reprocess vinyl window frames the same way. So really, the industry is already looking at that through the Vinyl Institute, and this is the responsible way
And
to
we'll
go.
yeah, and we'll be able to keep you posted on these initiative, because we stay close to the whole thing here. And Al, I know you're on that project too, and
Yes,
you're
yes,
so
we've been in discussion with the vinyl industry and with the Vinyl Institute of Canada, about this issue. Yeah.
yeah. So we have time for, well, we have two more questions. I just thought I would mention that Roberto wants to thank you for the clarification of NAF 11 to NAF 17.
Oh,
So
good. I'm glad that was helpful.
yeah, so I
Great.
just wanted to
Yeah.
pass that along. And then we have Nirojan coming back with a follow-up question. How much responsibility, um, just let me show it. How much responsibility do you think the manufacturers should have with the installation? Why aren't manufacturers telling more installers to use higher quality installation materials like high-end sealants? So uh, then again, I'll say we have a lot of shows where we spoke about that issue in particular, but maybe if you want to...
Window installation is becoming increasingly more complicated. Um, and, uh, more and more there's a need to address the installation of a window into a particular type of wall. And manufacturers have no control over the various types of walls and buildings that their products end up in. So, it puts a heavy burden on a manufacturer to somehow have to provide installation instructions for the 7 different ways their products can be installed in
Yeah.
walls. And whenever there's a project that has an enclosure or envelope consultant involved, they will want to define how that window is installed. So it's very difficult for manufacturers, especially when they serve multiple markets or a larger geographic area, to anticipate or provide detailed instructions to install their products in all these various scenarios. And really, that's why we have a standard like the CSA A440.4 installation standard, because window installation can be complicated. There's a lot of things to consider, and it's not. If a window manufacturer gave you a complete set of installation instructions on how to do everything right, it would be 50 pages.
Yeah.
And that's just for their window line, and another 20, 30 pages for the door line. So at some point, you have to say, no, we need to approach this through training of installers. We need to approach this through um, imparting the skills and the knowledge to the people that do the installation work, because it's more information is required than you can put on the back of a sticker on a window, or a 5-page pamphlet, or even a 20-page installation instruction, when you might need dozens of those instructions for the various products that you sell. And even then, they might not apply in all the jurisdictions where you sell your work, your products. So it's really not a simple product as it appears. And if you're in one market only, where everybody installs Windows the same way, then you think it's a simple problem. But when you see how broad the installation issues are across the country, it's a much more complicated product, because there are real big variations in how products are installed from coast to coast.
Okay. So we have a last question here. Will there be a 2020 edition of the National Building Code published this year? If so, do you know of any significant changes?
There will be probably significant changes, primarily in the area of energy. There are not anticipated to be any significant changes with respect to, NAFS testing and things like that. We'll see, reference to newer standards, NAFS 17. We'll see the Canadian Supplement 19. The A440 standard, the latest one, should be referenced as well in the 2020 code. So the bigger changes will come in the area of energy. And that's something we could, those matters are actually being discussed right now. Actually, today, there are meetings of the Energy Efficiency Standing Committee discussing the specific code changes that were out for public review.
Yeah, so it's one
what
of the
was
reasons
proposed,
we didn't have Robert, right, today. So
yes, that's one reason we don't have Robert, because he's involved in one of these meetings. So the long and the short of it is, yes, there will be changes in energy. Some pretty radical changes were proposed. There is, I heard, some pushback. And so it's kind of an open question as to whether those changes will proceed or not in this code cycle. But I would say energy will be the biggest area of change. The other thing is, the question was, when do we expect the code to be published? The most recent information available that I've seen shows a February 2021 publication date for the 2020 National Code. But some of the discussions are basically, because of COVID, the standing committees have not been able to meet in person this month like they normally do. They're trying to handle it by virtual meetings, and it's not clear that they will be able to finish in time for the February deadline. Okay. So I would say the earliest you'll see it is February 2021, but it might get pushed back another month or two.
I see. Okay. So to this question, will there be a 2020 edition this year? Technically, no. Okay, so it would be in 2021.
But even when the 2020 is published, it won't be adopted by the provinces for another 3 to 4 years at least. Because look at where we are now. We're at 2020, and it's only in 2019 and 2020 that the provinces have actually rolled out, across Canada, the 2015 code.
Okay.
So the 2020 code is not going to be actualized until 2023 to 2025. So that's kind of the time frame.
Okay. Well, so that's it for the questions. So maybe if you have a last few words, and
Well, I think we've covered quite a bit here today. Really good questions. I thank everyone who asked questions. They're very pertinent, important, relevant questions, and hopefully the answers have been helpful to you. I'm speaking from the knowledge base I have, and one reason I want to have Robert on the call next week is because he has an even deeper knowledge and a longer history with the code. And so I invite everyone to bring your code questions of whatever kind they are to next week's show. And Robert and I will be discussing code, what code expects of manufacturers, and some of the challenges around installation and other issues. So we're going to discuss some of these issues. We might actually have some slides on the screen, but our goal will be more to interact next week, and also to take questions and engage with our callers. So do invite you to bring more of your code questions next week.
Great. So I just want to thank again Quanix Building Products for a proud sponsor of this show, and we'll see you next week. Thanks again.
See you next week on Tech Talks.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.